Alright guys, let's take a look here. I'm going to start with the bone density side. Just because. I always get a kick out of focus beta. So it's focused beta. So here, if I draw this picture, so here I'm taking one woman. So don't have to change anything. How do I know I can do this problem? So I studied, Jeff. No. How do I know it's legal to look up probabilities?
It says normal.
Normally distributed. I like it. Because the sample size, there is no sample, so that doesn't save me. I've got to say it's normal. Because I don't have n greater than 30. So it is normally distributed. What goes in the middle? 2.9. So then here's my 2.5. And I want more than. So already I know the answer is going to be more than 50%. So if I get 0.2, I am wrong. Or my picture sucks, right? So draw your picture correctly and it should help you. So now what do I do? Calculate. Yeah, get a z-score. 2.5 minus 2.9 divided by 0.71. And what do you guys get? Yeah, negative 0.56. Jeff. Alright, I know some of you guys know the shortcut, that's fantastic. If you don't use the shortcut, you look up negative 0.56. I get 0.2877. That's down here. So then what's the right answer then? 0.7123. Yay. So 71% chance, a little over 71% chance that a woman's going to have a bone density more than 2.5 grams per square centimeter. These people up here are like basically ex-women. I don't know. Right, Wolverine going on. Okay. So what happens in part B? Why? Yeah, standard deviation's got to change because I did the two things. I took a sample and I'm asking about the sample mean. I'm not always going to be nice and bold it like this. You got to look for it. So the very first thing I'm going to do is figure out what the standard deviation is now. What do you guys get for that? Point
1152.
I like it. 115, or you can do 1152. I like it. Standard deviation's got to be at least 3 places. If you want to make everything 4 places except z-scores, do it. Then you're set. You're golden. So now, notice how it's basically the same question, right? But this is the probably one woman has more than 2.5. It's probably that 38 women have an average more than 2.5. Well, you don't have to do this. But how does the picture change down here? What fundamentally happens to the picture? How would it be different down here? You could do this. What changes? What did we just change? Standard deviation gets smaller. So the picture should be fatter or skinnier? Yes. So it should have more things getting squeezed in here. Right, just to overpronounce that. So the answer we get for this one should be bigger than the answer we got for this one. Because there should be less stuff out in the tail, more stuff above it. Alright, let's see that happen. So it's going to be the same picture, really. I mean, you can make it a little tall if you want to. I still want this area up here. Still got to make a z-score, but now I'm going to use 0.115. kind of awesome. I'm going to say this, and later you guys are going to, if you haven't already, you're going to think that I'm insane, but z-score formula never changes. It's always my score minus the middle divided by the spread. Z-score formula didn't change. The spread here just happens to be 0.115. Same z-score formula, right? What do you guys get for that z-score? That makes sense. Almost off the chart, but not quite. So below this, you get 0.0003. So then the answer is going to be, darn it, one more zero. 9997. These guys are getting like, I can't remember. Oh well. Is that what everybody got? Okay. All right. And then number 2, forgiving Jeff for, I didn't feel like talking about Florida. We hear too much about Florida as it is. Real quick, you guys, Florida is one of the few states where there's more freedom to disseminate criminal reports. And that's why it seems like Florida is full of insane people. Because they just happen to release more. I don't know if you guys know that. But you guys understand what I'm saying? If you watch any of the news, there's always some crazy Florida person that does some insane thing. And it's not that other states don't have crazy people, it's just that Florida reports on it more. So, anyway. Just like, I'm not, I don't care about Florida. I lived in Florida, I did my time in Florida already. Don't care. So here, what goes in the middle? 80.9. This is a true statistic here. This I had to approximate because I couldn't find it. But oh well, too bad. And I went from 78 to 82, so I've got to make z-scores out of both of these. What z-score do you get for 78? Negative 0.24? And what about for 82?
Negative 0.09.
How could it be negative?
Or wait, yeah, sorry.
Positive 0.09?
Yes.
Ooh, dissension, I like it. 82 minus 80.9. Now watch, I'm going to do a mistake right on purpose. Here we go. 82 minus 80.9 divided by 12.1. What mistake have I made? I'm not picking on anybody. Somebody asked me about this. And I always get about 35% that do this. Why is that not right?
Order of operation.
Yeah. This calculator, when I see a big-ass division bar like this, to make 82 a z-score, it would look like this, right? Big-ass division bar divided by 12.1. What does that big-ass division bar really mean? It means that these are together. So if we don't tell the calculator that those are together, it's at a disadvantage, poor little dude. Now it's the top divided by the bottom. I get 0.09? Yeah, that was a 0.09. Yay! How's everybody doing? I'd hope to God you could see that 82 is not 75 standard deviations away from 80.9. I mean, every step is 12 big. Holy shit. So don't just blindly, the calculator told me. Well, 2 then. You'll be like the next son of Sam. The calculator told me to kill those people. So when I look up 0.09, what do you get in the chart? 0.09? 0.5359, and we look up negative 0.24. 0.24, you get 4052. If you are somebody who has no idea how I'm getting those numbers, this is a bad place to be. Everybody should know how to read that z-score chart by now. Okay. And then to get the answer, you just subtract those two. And what do you get? 7, yeah. Thank you. Save it for myself. Okay, I like it. And then greater than 120. So you make the Z-score. What do you guys get for that Z-score? 3.23? How's that, everybody? You guys all right? Okay. And then if I look that up, I'm going to get this area, and I really want that area. So I'm going to look up 3.23. What do you get? 9994. That's the one I'm remembering. So then the answer is going to be point, which kind of jives with reality, right? It's probably you find somebody that's more than 120 years old. Really unlikely, right? Pick somebody random if they're 120 and 3 months old. That would really freak me out. Just pick them randomly. Yeah. Say again? I can't.
Can I leave the answers?
Leave the answers in.
Scientific notation.
No, I don't want to see that shit. I need to make sure you can convert it. But guys, 0.9994. How far away from 1 is that? 0006. I mean, do you really need a calculator for that? Some of you guys are like, yeah, dude, don't judge. That's my job. You should really be able to do that. Okay. So what happens on part 2? It's the same question as part 1A, but it deals with sample of 87, and I'm asking about the sample mean. Those are the two things that have to happen to know when to do what? Change the standard deviation. I love it. Because now I can't use the one that was good for individual babies. I got to use the one that's good for a group of 87 because that's what the shit I've got. Part A, I'm comparing this baby to everybody else. Part B, from the part 2, I've got to do this group of babies to all the other group of 87 babies. So I can't use the same spread number. Does that make sense? No? Okay. So the first thing I do is this little dude. So I get 12.1 divided by square root of 87. And I get, oh yeah, this is 1.297. You can make it 1.297.3 if you want to. Got to do at least 3 places. So when you make the Z-score, let me draw the little picture. Wee-haw. Where'd it go? 80.9, 78, 82. I gotta make 2 Z-scores. Oh shit. 78, 80.9. How are you guys doing out there? You alright? Okay. So I got 78 minus 80.9 divided by the new standard deviation. I got that. 224 negative? So negative 224. And then watch. Let me change that to an 82. Pop! So you get 0.85. Okay. Is everybody okay? Okay. And then you look up 0.85, and you get what area? 8023, I like it. I heard you back there, you're good. And then negative 224. 0.125. So when you subtract those, 7898. So just under an 80% chance some infant born in California now will live to be 78 to 82. Do you see how this is good for planning for the future? If I know roughly the percentage of babies who will be older than the current retirement age, and it gets to be like 60, 70, 80%, then we're like, maybe we should raise that retirement age, right? To keep Social Security solvent, all that kind of shit. All the problems we're doing right now could immediately be used for planning purposes, right? We got, I don't know how else to say that. Okay. So on the other side, Is this side good? Any more questions on this side? Okay, guys. So I put a little chapter 5 problem here just because, thankfully that one was bonus on the quiz, by the way. But, so this is going to go from what to what? 5 to 45, so how tall is it? 140. It's not 1 over whatever number this is. It's 1 over the length. That first problem we did just had a 0 at one side, so be careful. So how do I find this probability? I want that area there, right? So how do I find that area? How wide is it? 11. How tall is it? So it's 11 over 40. I don't know. 0.275. Everybody all right? You guys okay? All right. This one is really quick. 0. Why is it 0? Because there ain't shit out here. This says that only between 5 and 45 does things exist. So the probability x is less than 5, probability x is greater than 45, that's all. What about what it said the probability x is less than 45? 100%. How do you do? Oh! Alright, here's a part D. Here's a part D. What's the probability that x, oh I got it, that, what do you got, Jeff? 8 is less than x is less than 50. Do not do 42 divided by 40. You guys see that? What does this really mean then? Why is that 50 actually bullshit? Because the thing stops at 45. So what width do I really have in my distribution from 8 to 45? So what width is that? 37. So I do 37 out of 40. If you do 50 minus 8, you get 42. And 42 over 40 is bigger than frickin' 1. Do not write that answer down. If you can't figure out what you're doing wrong, say, I keep getting something bigger than 1, Jeff, but I'm not sure. Write that down. I'm not sure what I'm doing. Then I'll go, oh, thank God. At least you know the answer can't be more than 1. If you write down 1.2 or something, I'm concerned. Right? You guys understand what I'm saying?
No.
Why?
I don't get it.
Well, shit. Now look. So if I said 8 to 50, so let me draw this again. Here's 5, here's 45. So if I go 8 to 50, right? I can't just do 42 out of 40 for a couple reasons. One is that's not the width that's in my distribution. My distribution stops at 45. But almost more importantly, this is bigger than 1. What's true about any probability? It cannot be bigger than 1. So don't write down here that this is whatever the shit it would be. When you do this division, 105% so much.
105.
Yeah. Right? So that's, don't do that. So that should be a red flag telling you, oh, I did that wrong, man. Here's the actual, in my distribution width, it's going to be 37. So the real answer would be 37 out of 40. And you know, whatever the hell that is. 0.925. All right, so that's a really good question. All right, then these at this point should be really simple. 1.76 goes up here, so then I know my answer is going to be bigger than 50%. I look up 1.76 and I get 9608. And I'm done. People normally do too much with this problem. This is strictly a, do you know how the hell to use that chart question? That's all that question is. It's already a z-score. It's asking for less than. You just got to look it up and be done with it. What about this one? Where the hell would the 23rd percentile be?
To the left is 0.
To the left. And then where's 0.23 go? in here, right? And what am I trying to find? That is the area. I'm done if that's what I'm trying to find. So it can't be what I'm trying to find the z-score that goes with that. So when you look up 0.23, what am I doing wrong? 0.23. There's the answer. I just did everything wrong. 0.23 is not a z-score, so I can't look for the free. It's an area. Oh shit. And I know it's negative, isn't it? Because it's down here. So 0.23, the closest I can get could be this. And that would be a z-score of negative 0.74. Done. It's not another decimal point, but all right. What's up? Everything all right? Yes. Okay, guys. 2 more here and then bonus. Yes.
Wait, so for those problems, you can't just subtract the number from 100 and put the decimals from this?
Which problem?
Like for the percentile one, you know,
For this one. Yeah.
0.23, like 0.74, it's obviously going to be that because it's out of 100. Like you can't just subtract it from 100 and get your answer.
Well, all right.
Or like the 100%.
If you do 100 minus 23, you get 77. And that has nothing to do with the question because that would just be the percentage above. If somebody's in the 23rd percentile, that means they scored below 77% of the people. So you're not really answering the question. What score is in the 23rd percentile? So 23 is an area. It's a percentage, right? So normally I use the z-score to look in. Now I find the area and look out to get the z-score. So the closest I got was 2296, and that z-score, if I look out, would be negative 0.74. Yeah.
It just came close to 100 when you had it.
I know. Except for one of them is negative. That's the problem. All right. So number 3, what goes in the middle? 71.6. So I want to go from 50 to 70. I know my z-scores are both going to be negative. Stay with me now. Oh my gosh. So here I get a z-score of what? Negative 257. And again, in case you didn't get this far, this would be 50 minus 71.6 divided by 8.41, right? X minus the mean divided by the standard deviation. And for 70, what would the z-score be? Negative 0.19. Okay. So when I look up negative 0.19, I get an area of 4247. When I look up negative 257, 0.0051. And then you just subtract those to get the area in the middle. So you'll get, I don't know, what do you get? 4141, I don't know, what do you get? 4196. Okay. Now this one starts off just like this one, except now I want a grade as an answer. So I have to first find the z-score that goes for this, the top 10%. Why do I not look up 0.10 in the chart? Because the chart only understands areas that are below. I like it. So 10% above, there must be 90% below. So when I look that up, what z-score do I get? Yeah. 90. The closest I get is this dude here. And that would be 1.28. No, 1.28. And then I got to convert that back into a grade, so I use this little dude here. That's the one that goes back to a raw score. 71.6 plus 1.28 times 8.41, and and then whatever the hell that is. 82.36. So if somebody scored above that grade, they are in the 10th percentile at least, or 90th percentile. Top 10%. Now this one, this is getting at the probability of flipping a coin and getting ahead is 50%. So what the shit does 50% really mean? It doesn't mean a damn thing for one flip, to be honest. It only makes sense in the long run. So the answer to number 3A, you want to look at this as, what's that P represent?
Probability.
Or percentage. So the percentage of grades between 50 and 70 were 41.96%. That's truly what that means. Okay. I like it. Let's take a break. Yeah. When we come back, we'll create the formula sheet. I'll give out the practice test answers, and then we'll just open it up to whatever questions you have for the test tomorrow.